In this video, I'll be demonstrating the shrink test procedure that I've developed for the for 3D printing. The test consists of 3 pieces like these. One of them is printed sideways like that. That's piece A. It's going to be your strongest print. Piece B is printed like this. This is a piece B right here. And piece C is printed straight up and down. That's going to be your weakest piece. Piece A with strongest, B will probably be in the middle, and then C will probably be the weakest. The test consists of 2 parts. One is pulling through the eyelets there and measuring the elongation and the pressure applied to create that elongation and ultimately break the piece. Okay, so here's the test fixture. It consists of a drill press, a load cell which is connected to a strain gauge amplifier, and a large caliper. The test will work like this. I will slowly raise up on the drill press handle, which will add tension to the piece here, and we'll get a reading over here. Every 10 pounds or so I'll record the tension and I'll record the elongation measured here on the caliper. So I just have an Allen wrench going through the bottom hole here and wedged underneath the drill press, or underneath the vise to keep it steady. I have another Allen wrench going through this hole, which is secured to the eye bolt coming out of the load cell with this wire halo. The purpose of the wire halo is to evenly distribute the weight on either side so that we're not pulling up on one side more than we are on the other. So starting off, we'll zero the caliper. I'll come up in tension. Okay, I'm starting the test now. I have my caliper zeroed out. And then slowly come up in tension. 10 pounds. I have 0.26 millimeters. 20 pounds. I have 0.64 millimeters. 30 pounds. 0.83. 40 millimeters. I have 0.129. Yep. And we have parts breakage around 40 pounds. So this I expected to be a pretty weak part because it's printed this way. The printer adds each layer along this plane. The strongest part, which I've already tested, is printed along this plane. So now that this part is broken, it's not done. There's one more test we're going to do with this. In addition to testing each piece pulling this way, we test each piece pulling from the center up. So this piece, A and B, are sort of interchangeable since they're just a rectangular piece. We want to get a test pulling with the grain like this, and we want to get a test pulling against the grain like this. I've already done the against the grain test. I'm going to demonstrate the with the grain test. It should break pretty easily. So for this test, you can see I've wedged the piece itself actually underneath the vise like the Allen wrench was wedged before. So we're just going to do the same test. Okay, here we go, starting the test. This is test piece B, pulling against the grain. 6 pounds, 0 millimeters of deflection. 15 pounds, 0.04 millimeters. 25 pounds, 0.48 millimeters. 30 pounds, 0.83. 40 pounds, 1.37. 50 pounds, 1.87. 60 pounds, 2.46. 70 pounds, 2.9. 80 pounds, 3.46. 90 pounds, 4.29. And it broke around 100 pounds. So I'll take these numbers and populate a spreadsheet with it and create a graph that will show the elongation and the deflection and the force. So there's our broken piece. Took 100 pounds to break it. Also worth mentioning is that I started out doing these tests with the $5 fish scale, and it worked right up until the parts broke, and then the recoil caused the needle to no longer land on 0. The meter is still usable, but it just it doesn't go back to 0, so you have to do some math.